Hi, I'm Cheryl Leach. In this problem, we're going to find the function that satisfies the differential equation f double prime of x equals 2, along with these two initial conditions. But before we do that, let's review the inverse relationship between differentiation and integration. I know that if I begin with a function, I can use differentiation to get the first derivative and then the second derivative. But because integration is the inverse operation, if I start with the second derivative, I can integrate to get the first derivative and integrate again to get the original function. Now remember, when we were taking higher order derivatives, we had to go one step at a time. There was no shortcut to take me from the function to the second derivative. The same is true for integration. No shortcuts from the second derivative back to the function. We have to go through the first derivative. So let's see how this works in our problem. I'm given the second derivative of x, and it's equal to 2. So to find the first derivative, I'm going to integrate the second derivative. Again, think inverse process. I have a second derivative, I'm going to integrate it, that will undo the first differentiation, and I end up with the first derivative. So I've got the integral of 2 dx. Well, that's a fairly simple integration problem. It's just 2x plus a constant. Now we have to figure out what that constant is. Well, I can use my first initial condition to help me out with that. I know that when I plug 2 into the derivative, my answer will be 5. So when I evaluate my first derivative at 2, I have 2 times 2 plus my constant of integration, and that has to equal 5. This means that 4 plus c is 5, and so c equals 1. That tells me that my first derivative is 2x plus 1. All right, so far so good. But I really need the original function. How do I get that? Well, to get my original function, I have to integrate the first derivative, which I now know is 2x plus 1. Again, not a difficult integration problem. I have a constant multiple of 2 that I can pull out, and integrating x, I have x squared divided by 2. The integral of 1 dx is x, and I have another constant of integration. Simplifying, I have x squared plus x plus c. Now it's time to use that second initial condition to help me figure out my constant of integration. I know that if I plug 2 into my function, I'll have 2 squared plus 2 plus a constant, and the result has to be 10. So I have 4 plus 2, which is 6, plus a constant equals 10, and my constant of integration in this case is 4. If I put all of this together, I know that my function is going to be x squared plus x plus 4. I hope this was helpful. Thanks.